Okay, here we are again. Some of you are getting ready to love me, and some of you not so much. You're gonna not like me after we get done with today's video. But today's video is about determining the coefficient of determination and how to use our calculator to most efficiently find that value, and therefore so we can interpret it based on the scenario we're working with. So we're going to be continuing the problem about the caribou versus the wolf population in Denali National Park, and you're going to need your calculator for this, so I hope you have it with you. Hang on. Okay, as I said before, you are either getting ready to love me or to hate me. But the purpose of today's video lesson is to talk about coefficient of determination. And essentially, the coefficient of determination is indicated by r squared. And that means we're going to take the r value, the coefficient correlation, and we're going to square it. And what this will give us is the percent of variation in the response variable that is explained. And basically what we mean by that is the amount of variation in our response variable, or in our y, our output, that we expect to have based on our r value. How strong is the correlation? So in order to find the coefficient of determination, we're going to need to find r, right? The correlation coefficient. So let's go back to our caribou and wolf problem, because we know that we have 7 x and y data sets, and we know because of our previous work that we're going to have x and y in lists 1 and list 2, and then I taught you how to do x squared and y squared and xy, how to fill in your data table, get your sigma down here, or the sum of all of these. Now here is where you are getting ready to get angry, but it's okay. Let's see if turning on the light will make this a little bit clearer. I don't want it to glare on you. So first thing I'm going to do is clear my lists. So if you remember, that second memory, clear all lists, is number 4. So I'm going to approach this problem like I have done nothing yet. I'm going to go into the lists, and I'm going to edit list 1 and list 2. So I'm going to put my x values 30, 34, 27, 25, 17, 23, and 20 into my list. Now if you look, it's ready for value 8, correct? And that tells us that the last one we did, if we go up, was 7, our 7th data value. And that's correct because we know we have 7 data points. So we're going to, in list 2, we're going to put our y's, 66, 79, 70, 60, 48, 55, and 60. So now, at this point, this is where I taught you to go over to L3 and enter your x squares, and L4 and do your y squares. But your calculator actually has the capability of doing this on its own. So if you go back to your home screen, you go to Statistics, right arrow to Calculate. We have 2 variables going on here, x and y. So we're going to go down to number 2. We're going to calculate 2 variable statistics. My x list is indeed in L1. My y list is in L2. I have no frequency. I'm going to hit the down arrow until my calculate is flashing, and I'm going to hit enter. And if you look, it gives us our y bar, which we need to find the least squares line, gives us the sum of our x's, it gives us the sum of our x squares. You don't need the other two values. It tells us that n is 7, which is helpful in case you have a ton of data, and I have sent you that data via the Navigator system. If you scroll down, you notice you have y bar, sigma y squared. Keep going, you have sigma xy. So you have all of the summations that you need for your table. You also have your minimum and maximum x value, so you know the boundaries within which you can interpolate. So everything that we have been spending a lot of time using the tables to calculate can be found using your two variable statistics option. Now we're going to take that one step further because we've been using all of these pieces to find the R value, or the correlation coefficient. So if you go back to your home screen, usually what happens, and what's happened in class, is that if you go to stat calculate number 8. We use the linear regression a plus bx in statistics, so 8. I have list 1 and list 2 is where my data is. Remember, you can store this regression equation already in your y equals editor. If you hit alpha trace, it brings up your y equals. Hit enter, and it's going to paste that directly into your y sub 1. Go down to calculate and hit enter. Well, we learned previously that that gives us our slope and our y-intercept. Our y-intercept of 22.4 and our slope of about 1.6. But your calculator has the capability of giving you r and r squared. So if you'll quit this and go to your catalog, second 0 brings up your catalog, which is essentially an alphabetical list of everything that your calculator can do. If you will hit D, if you'll see the little green D on the x to the -1, that's going to bring up all of your D functions. Use your down arrow to get to diagnostic on. Hit enter, and that tells us what function we are getting ready to have the calculator perform, and we do want to turn that on, so we're going to hit enter again until it says done. Then now if you go and you calculate your linear regression on 8, and again you can go ahead and paste that into your y sub 1 and calculate, it now gives you your R value of 0.91, and now the new term that we're talking about today, which is your coefficient of determination, of 0.837. And typically what we do is we change this to percent. So we have a fairly strong correlation with our wolf and caribou population at about 0.92. And R squared is 0.8, let's call it 0.84. That means 84% of the variation that occurs in our wolf population we expect to happen because of the strength of our R value. So if you think about that, 100% minus the 84% that is explained, 16% of the wolf population is unexplained. Those are the things that just happen by coincidence, happen by chance, or possibly are affected by lurking variables that we don't know. But ultimately, what we have done today is we have determined how to use our calculator to find the summations for our tables, to turn the diagnostics on so we can indeed find the R, or the correlation coefficient of 0.92, and the R squared, the coefficient of determination, which tells us 84% of our response variable can be explained, and therefore 16% is unexplained. So we'll explore this more in class with some SAT verbal and math scores. See you tomorrow.